11s, we're back. Second part of this video, right? More algebraic fractions. Right, similar sorts of things. I did mention briefly last time that in some instances we might want to simplify things by factorising, cancelling common factor from the numerator and the denominator. Right, factorise by whichever method you can, and then cancel. So, first one here. This one's pretty nice and easy. So I can take a common factor of 2 here. That's going to be out of 3x plus 4. And I could say, look, that's 2 times 3. I don't have to, you know, but cancel those. And that leaves me with 3x plus 4 over 3. Don't cancel the 6 and the 6. That would be an unwise move, right? Because we have 2 terms up there. I've got to cancel the same thing from both of them. Okay, there we go. Nice. Next one over here. Well, are they common factors? We're going to factorise and find out. I could think there will be. So this is x outside of x minus 1. And this, remember, difference of 2 squares is x plus 1, x minus 1. Righto, and the x minus 1's cancel, and I end up with x over x plus 1. There we go, cancelling out. Always be careful, you know, if it's possible to do that at the end, well, do that. Right? It's not simplified, just the same as you wouldn't leave an answer as 2 over 6. You would simplify that the same if I have a common factor that may be algebraic. Righto. Multiplying and dividing algebraic fractions. Multiplying fractions is easy. Multiply the numerators, multiply the denominators. Maybe you might cancel some factors before you get there, but it's not very complicated. Dividing, one little trick, and then it's fine. So, let's have a look here. Have I got any common factors? Well, I'm going to rewrite this in a couple of ways. I'm going to call that 2a over difference of 2 squares. A plus 3, a minus 3. Easier to factorise and cancel early than late, because it can be difficult factorising these cubics or something. Right, I need a bit more space there. Times a minus 3 over 5a. Right, well, here's an a and here's another a. Cancel those ones. Here's an a minus 3 term. Right, so that leaves me with 2 times 1 up the top. 2 over a plus 3 times 5. Say 5 outside of a plus 3. 5a plus 15 if you like, but you know, factorised is generally better. There we go, that's that first one done. Nice. Second one, hopefully you can remember how to divide by a fraction. How do you do it? You multiply by the reciprocal. Turn this second one here, turn it upside down, and then multiply. Righto, there will be some factorising going on here too, so I'm going to do 2 of those things at the same time. The 12x over x plus 1, I'm just going to leave, not going to factorise that because I can't really. But this fella here, x squared plus 2x plus 1, well, I reckon that's a perfect square. That's x plus 1 all squared. Okay? Square the first, twice their product, square the last. That's x plus 1 all squared. So, this is going to be the equivalent of 12x over x plus 1 times x plus 1 all squared over 6x. I reckon heaps of stuff's going to cancel here. Well, I could take a 6x out of this, and that would leave me with 2. Right, cancels there. The x plus 1, well, it's a pair of x plus 1 sort of thing. So I'm going to cancel one of those with this term here, and that gives me 2 outside of x plus 1. And the denominator, oh, I've cancelled everything, so that's just over 1. I'll just leave it like that. 2 outside of x plus 1. Who would have thought? Beautiful. Righto? Beautiful. That's it. Oh, wait. Simplifying compound fractions. What do we do here? Well, there's a little bit of a trick here. Going okay for time, we're not doing too bad. I might have fractions inside fractions. Righto. What we want to do, the lowest common multiple of everything. Read these things here. Multiply everything by the lowest common multiple, and we should get rid of all the fractions, and then we should be able to deal with it. So, right, this first example here doesn't even have any algebra in it. Well, what is the lowest common multiple of all of these things? I reckon it's 12. Okay, so we're going to multiply each of these fractions by something, top and bottom, by something, so that everything has a denominator of 12. Right, so this is going to be equals, right, 6 over 12 minus 4 over 12 all over 3 over 12 plus 2 over 12. Right, that equals 2 over 12 all over 5 over 12. Right. Now, if we think about a fraction divided by a fraction, right, really, in a way, we could say that equals, and we could just cancel the 12s, but just look at this as a reminder of what we've just done. That's the same as 2 over 12 times 12 over 5, isn't it? Right? Divide by the reciprocal. 12s go, and that equals 2 over 5. Okay? Righto, so once we've got everything over that common denominator, we can cancel them. Let's look at one more example here, and we'll be done for this video. It's getting a bit long already. So, I need a common denominator. What's it going to be? It's going to be t, okay? So I'm already over t here. Leave that 1. So this is going to be 1 over t plus t over t over 1 over t. Oh, that's not 1 over t, is it? Over 1 over t minus t over t. Look, we can scrap all of these t's in the bottom now. All of those denominators are the same, right? So we can get rid of all of those, and I can say this is 1 plus t over 1 minus t. And that's it, done. Okay? 1 plus t over 1 minus t. Compound fractions. Handy thing to look at. That's it for our algebraic fractions. We've got a fair bit to do in class, you can see. Good to get these skills up and running. Sometimes standalone questions, sometimes part of a bigger thing. Anyway, I'll see you then. Thanks, guys.